In this problem, we're given this integral, and we're asked to use the trapezoid rule to approximate the integral. We're going to use n equals 4, n equals 8, n equals 16. We're also given that a is equal to 5 and b equal to 10 on this problem, so we'll plug those values in ourselves. And we're given the trapezoid rule here, which is 1/2 times the first value of t in the function plus the next value plus the next value, and all the way to the last value, which will also get multiplied by 1/2. And then times delta t. Delta t is b minus a over n. A and b are these numbers here. Okay, for this formula, this a and b are different numbers. This is that a and that b, so that might get a little confusing. But our interval to find our delta t is just our endpoints. So we're going from 0 to 2 pi. So those are our endpoints, 2 pi minus 0 over n, and we're given our n values. Okay, so let's do n equals 4 first. Okay, so n equals 4. Okay, so given that our function f of t is equal to the square root of, let's see, 5 squared, that's 25 cosine squared t plus b squared, that's 10, 100 sine squared t. Okay, so that is our function. And let's see, what is our delta t? Delta t, we already talked about a second ago, but it's going to be 2 pi minus 0 over 4 because we have 4 subintervals, so that's pi over 2. So that gives us our delta t here. Okay, and then our function values will go in here. Okay, so what I'm going to do to figure this out, I'm not going to do it all by hand. You definitely can, but I've typed in the function into the calculator. Okay, the square root of 25 cosine x squared plus 100 sine x squared, x quantity squared. Okay, and you can look at your table of values. I've plugged in a few of those already. We get, let's see, for 0, we get 5. For pi over 2, we get 10, and so on and so forth. Okay, so we have the values there. And for this, what are our t sub 0, t sub 1, t sub 2, t sub all the way out? Well, we know we have 4 subintervals, so we need to know if we're on 2 pi, every pi over 2 is going to be a subinterval. So we'll start at t sub 0 is equal to 0, and then t sub 1 is equal to pi over 2, t sub 2 is equal to pi, t sub 3 is equal to 3 pi over 2, and t sub 4 is equal to 2 pi. Okay, so those will be our interval, our numbers that we'll plug into the function value here. Okay, so what we're going to get for t sub 4 is 1/2 times, let's see, f of t sub 0, which is f of 0, plus f of pi over 2, plus f of pi, plus f of 3 pi over 2, plus plus 1/2 f of 2 pi. Why did I put the half there? Well, it was our last one that we're plugging in, so it's got the half. And then our delta t, of course, is here, so pi over 2. Okay, so you can plug those values in. We already know what they are, so this one's pretty easy to do. But another way of doing that, if you want to do this in the calculator, which I like doing at the calculator, we can use the calculator. So there's the 1/2, and then we hit vars, go over to y vars, and hit enter on y1, and then I'll tell it the value that I want to plug in. So I'll put a parentheses there and open up 0. So that's basically the same. That is the same thing as saying f of 0. So since I have this typed in y1, when I put y1 of 0, it's the same as f of 0. Okay, so plus vars, y vars, and this one would be a pi over 2. And let me go ahead and finish these real quick. And there we go, but I missed the half, so let me make sure to put that half in the last one. Remember the pi over 2 one has a half in front of it, so I'm going to insert and put a 1 divided by 2 there. Okay, so that gives me the inside It doesn't give me the extra pi over 2. If I want to go ahead and do that, I can put a parentheses around that, but I have to put parentheses around the beginning as well. Okay, so there it is. I've got parentheses around the beginning and end, and I'll multiply it by pi over 2, and there's my answer. Okay, so I get 47.124. Okay. All right, so for the next one, that is the approximation of the area with n equals 4. Okay, so for the next one, we're going to use the same formula, but we're going to have twice as many values on this one. So for t equals 8, or t of 8 within 8 subintervals, okay, so the first one would start at 1/2 of f of 0 still. Okay, but now we're going to be going, instead of pi over 2's, our delta t is going to be divided by 8 here. Okay, so if we're divided by 8, 2 pi divided by 8 is pi over 4. So we're going to be going by pi over 4 now. So our next one would be f of pi over 4 plus f of pi over 2 plus f of 3 pi over 4 plus f of pi plus, and I'm not going to write all those out, I will write them in my calculator, and my last one will be 1/2 f of 2 pi, just like last time. Okay, and that's all multiplied this time by pi over 4. Okay, so again, go to the calculator. I typed this in ahead of time, so there we go. Give you a sec to take a look at that. Okay, so I've got every value there. There's the pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 1/2 times 2 pi. Okay, and if I want to, like last time, if I want to go ahead and multiply that by the delta t, okay, I can do that. And let's see, I'll multiply by pi over 4. Okay, and there we go. So for this one, I get 48.4. Okay. Now for the last one, if we find our delta t for 16 subintervals, this is going to take some doing. We need to first figure out delta t. Remember up here, if our delta t first was divided by 4, next time was divided by 8, and next time is going to divide by 16. So we're going to be going by pi over 8ths this time, okay, which is going to double the amount of things that we have written in here. Okay, so we would start with 1/2 f of 0, just like last time, but then this one would be f of pi over 8, and then we would have the f of pi over 4, and then the next one would be f of 3 pi over 8, and then we would have f of pi over 2. So you can see, I'm just going to put dot 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 here, and we would still end up with 1/2 f of 2 pi on our last one. Okay, so as you can see, we're just adding an extra one in each time. But this pi over 8 wasn't here, but now it's here, and then this 3 pi over 8 wasn't here, but it is here now. Okay, so we're adding in these values into every other one, so we're doubling the amount of values that we're taking, and then this out here is going to be times pi over 8. Okay, so what I can do is kind of use my what I've already typed in. I've typed in this was for the 8 subintervals. Okay, so if I want, I can just use that and then type in the missing ones. Okay, so I know all of them there, but I need to do the pi over 8 one. So the pi over 8, 3 pi over 8, 5 pi over 8, and so on. Okay, so I'll add those in. Okay, so that one would be pi over 8. Three pi over 8. 5 pi over 8. 7 pi over 8. 9 pi over 8. 11 pi over 8. 13 pi over 8. Almost there. 15 pi over 8. Okay, so that should be the last one, because if we go 1 more power over 8, that'll be 2 pi. Okay, so that will be the inside. I'll go ahead and hit enter on that, and I get 123.35, but I haven't multiplied by my pi over 8 yet, so I'll take that and multiply by pi over 8, and I get, for that value, 48.44. Okay, so that's enough to tell us if we're rounding to 1 decimal place. It looks like that this 48.4 is good enough. So we're going to say that our final numerical answer for this is equal to 48.4.